In this tutorial, what we will be discussing is the second part of the review for the Chem 119 final. Alright, first of all, you need to make sure that you know all the common names. For instance, methanoic acid is formic acid, ethanoic acid is acetic acid. The reason why I threw this in here, not only will you be asked direct questions about it, but you might see the words interchanged throughout the exam, and I don't want you to freak out because you don't recognize a word. When you really do, you just didn't bother to remember that the reference to the IUPAC name. Alright, also we talked about this in the last video. Know how these break down. So for instance here, we would break it down here, draw the line between the O's. The double bond is part of the carboxylic acid. The oxygen that's inside the molecule is the alcohol. So therefore, the alcohol was 1, 2, 3, so it's propanol. And then the left-hand side, with the double bonded carbonyl group, is 2 carbons, which should be ethanoic acid. Or notice here it actually says acetate because it could be considered acetic acid. Because once again, that's the common name. On the right hand side, draw the line between the oxygens. The one without the double bond is the alcohol. You name that one first. We have 2 carbons here, so that becomes ethanol. And then on the left hand side, we have 1, 2, 3, 4 carbons, becomes butanoic acid. Or butyric acid. Alright, base hydrolysis, which is saponification, is the reaction of an ester with a strong base. It produces a salt of the carboxylic acid and the alcohol. You break it down, the OH, the O and the H split apart, which is unfamiliar to you because you always see OH as a whole. But with the saponification, the O and the H is where it breaks. The oxygen comes around and attaches itself to that carbon. So that's why you get that oxygen there. And then the sodium comes along with it. The oxygen is what's bonding to the carbon, not the sodium. And then the hydrogen that's remaining goes to that oxygen to do the alcohol. Actually, technically, it goes the oxygen is attaching that to that hydrogen. But either way, the OH goes together. Alright, so saturated versus unsaturated. Saturated means it's all single bonds. Unsaturated is one or more double or triple bonds. When we're talking about lipids, we're typically talking about double bonds. You need to know the differences physically and chemically between waxes, fats, and oils. Waxes are solid, and they are just one long chain, whereas fats and oils are on a glycerol, which is 3 chains of esters. So waxes is just one chain of an ester. Fats and oils are 3 chains of esters. 3 chains of esters all attached on the glycerol, called an alkyl glycerol. Fats are solids, oils are liquids. Fats are saturated, oils are unsaturated. So fats have all single bonds, oils have at least one double bond in there. Hydrogenation is when you add hydrogen across a double bond, and it's used commercially to convert oil into margarine. is making it more solid by reducing the double bonds and making it more single to make it more similar to those fats. Okay, soap, you have one polar chain, one polar end followed by a really long hydrocarbon chain. The hydrocarbon chain mixes with the oils on your skin, and then the polar end reacts with the water to pull the oils on your skin off. And that's how soap works. There's actually a full page on how this works in your book. You might want to read over it. No solubility of lipids. Lipids do not dissolve. Fats do not dissolve because they are all nonpolar. And how glycerophospholipids are different. The fact that phospho is what you're going to be looking for, it has a phosphate group in it. Because of the fact that it has a phosphate group in it, it has some electronegativity there, which means it can actually interact with water. So glycerophospholipids have a nonpolar side and a polar side, so it can react with both. And that's what our cell membranes are made of. Alright, finally for this review, know the differences between the types of liquids. Wax, we've already talked about, is a single ester and is a solid. Fatty acids are that again. It's the generic term. Trialkylglycerol. Those are nonpolar. They do not react in water. They do not dissolve in water. That's the one where they have the glycerol with the carbon chains, the esters coming off of it. The steroid is the one with the steroid nucleus, where we have the geometric shapes. And then the glycerophospholipid is the one that our cells are made of, where we have phosphate in it, and the phosphate ends up interacting with the water, making it able to be dissolved. But only that side of it can be dissolved. Alright, and that is the second part of your review for Chem 119 Final.